eclipsing binary, eclipsing binaries. I have another presentation I put together on eclipsing binaries, but I was going to talk through this other project I was working on here, looking at the SX. So they're not. I'm from Phoenix, and so there's a Phoenician resort here in Phoenix. So I want to call these things SX Phoenicians, but I know that's not how you pronounce their last name. But
Okay.
the variable star is over here inside the cluster. So let me work through this one. I got the other presentation I can pull up if we want to take time, but I know there's a lot of other things to discuss. So so this one's specifically looking at these time series variables. So the objective here is to see if whether our imaging and photometry analysis capability we have with both the 1 meter and more essentially the DK64, if we can actually pick up enough fidelity in the period of the variables to see if we can tell anything over time. So I went back and tried to find some papers. This is one back in 2014 for why we want to be doing this. So here's a paper that came out of, doesn't say where. So, but they're looking at the variables inside this other cluster. There's some light curves of the variables there. This is conclusion from this paper here. And that's older still. It's back in 2007. But they're saying, it's important to view these things, right? It's important to take required measurements over a few years' time. So with that kind of laying the groundwork, I went in to try to say what we can do with it. I took some of the data before, and my process again is taking the imagery data, the photometry data, or the imagery data that we've been provided using what do I use? Astro Image J to reduce the photometry, and then I kick it into Paranzo to look at period analysis and such. So here's one of the variables we had before. Very, very nice curve on this. So it's like, oh, we can pick up variability in that. Here's on the right, same curve, but it's background stars. I'm just testing against the field stars in the area. So what I did is I took a master list of all the variables published in the cluster, went out and pulled the March and April data. And, some of them are not visible because the field of view is off a little bit. Other ones I went back and checked, and actually, it's a very crowded stellar field. So some of them are overlapping with other stars and such, so you can't really pick out an image. So initially I came up with a list with, well, we got 1, 2, 3, 4, 5, 6, 7 that I had data both from the March run and the April run. Okay, so I'm looking at the comparison of the periods for these variables over those two runs. So this next set of slides is just showing each one of those individually. We don't have to go through all this, but at the top here is the light curve, Alaparanzo. So on the left is always March, on the right is April. And then the next block down is basically I'm doing a bending of like every 5 data points. So it's kind of showing you the curve in there. And then the last little block down there is actually the phase curve. Okay, so we got the light curve, bended data on the light curve, and then the phase curve at the bottom. And so using Paranzo, I was just using a Scargo period analysis program because, Paranzo has like 10 or 12 different period analysis programs you can use. So that's another whole study in itself, which one's appropriate for which situation. So I just use Scargo at this point just to try to get something done. Take the period from the March and then the April. So then going through, like here's the next one, 499, right? Phase curves look a little different. Some of these, the April photometry is a bit better than the March, vice versa on some of the other ones. So another variable, this one, both of them were a little noisier, right? This one, the April is much noisier than the March.
Doug, let me ask
Yes.
you what the phase curve means. Is that after you've tried to fit this to some periodic function? This is like the residual, or what's the phase curve mean?
Oh, the phase curve is just Yeah, I'm taking the light curve and folding it over,
Yeah.
and basically, it's not the residuals. It's just looking at the daylight,
Oh, I got it. You
over
fold,
top.
yeah. So you,
Yeah,
you take each one of those periods,
right.
you fold them
Fold it.
on each other using the frequency, the period that
Period
you
that
calculated.
I found, right? Yeah, that came out of Paranzo. So this one I ran a period analysis, came up with this period over here, used that, folded the light curve over on itself to produce the phase curve on the bottom.
And is that from 0 to pi? What are the units on the phase on the
Yeah,
bottom?
this is one I guess be full curve 2 pi, and
Oh,
this
one is one
full,
full period.
so it's a double period. So
Got a double. Good to double period.
yeah,
Got it.
yeah.
Uh-huh.
So
Also, Doug, it looks like the middle is the maximum. Is that by, have you like shifted those over so that the middle is the so that phase one represents a maximum, or did that just happen to come out that way?
yeah, it just came out that way.
Okay.
Yeah, I wasn't doing any monkey business with it. So
Well, does Paranzo do it that way, I wonder?
I think Parenzo lines it up like that. So
Because I know for EBs, the convention is to have to put that phase one would be the minimum light.
okay.
And I'm curious what it is for these SX PHE stars, what the convention is, but yeah, it's cool, interesting.
Yeah, I don't know. I'm still learning, depths of
Yeah,
Parenzo.
the convention is for eclipsing binaries, you do minimum. For variable stars like this, you do maximum.
Okay,
Thank you, Russ.
okay. So
And what is the mechanism for the variability of the light? I'm not familiar with these SX Fine.
Venetians, yeah.
Right.
What do you mean the variability of
The mechanism is eclipsing, or what's the variability mechanism?
No, they're not eclipsing exactly. Go ahead.
Seismology, right? Like
Yeah, I think there are lots like Cepheids. So they've
Yeah.
got the atmosphere, it gets pumped up and expands out, cools, and comes back in.
Cool. Okay, that's
So they're like delta Scutis and
Yeah,
Cepheids.
basically, yeah, pulsating type variables.
Okay.
So
Yeah,
different.
so it's interesting that so sometimes the March date is better, sometimes the April date is better. That's
depending on where it was in the cluster, if it's in a crowded field or whatever. So yeah.
What's the brightness of these typically, Doug?
These are down around 13, 14, 15 magnitude. Somewhere in there. When we get above about 15th magnitude, then it becomes pretty hard to get a light curve on them. So different ones have different shapes. Go ahead, Dave.
Yeah, that's really really quite nice. This is with was this with the CDK 24?
Yes.
Yeah. So this is a 600 millimeter telescope.
Yeah. So we can get some pretty good data on this stuff.
And I'd love to know what the actual magnitude is if you could dig it out sometime, because that's quite nice.
Okay, sure. Yeah, I've got more work to do. So
and I'd love to see the star field that it's in to see how difficult the photometry.
Okay. Yeah, I should probably plot that in the middle or whatever, so we'll know exactly where we're trying to image, right? Okay, sure. Somebody else had a question, Colin? No? So this just keeps going, right? We don't need to go through all these. I mean, I'm just showing you all the ones I imaged. So again, see, March, really nice at the top here, really nice imagery, right?
Yeah.
April's pretty noisy, right?
Be interesting to know.
Are these 30-second exposures?
These are the 30-second exposures. So.
Okay.
That seems to work the best. I did some analysis on where we did a 2-minute exposure, right, when we're trying to find the eclipsings, and the 30 seconds seems to work, at least for these variables, works a lot nicer. So.
The periods are so short, I didn't expect that at all. And the peaks are so high that I think if you'd go much longer than 30 seconds, you'd lose some resolution at the top of the peak.
Yeah.
Yeah, all these periods are very short, which makes it nice because we can, you know, get a lot of periods out of these things we image them.
And these are all known variables. They all have a v so and so number,
Right.
so they're already known. But
They're already cataloged,
how-
yeah.
how do the periods that you derived compare with the previous
Public periods,
observation?
yeah. Good. So excellent question. So
Oh, I'm a
here's my
straight man
table,
for you.
but I didn't have time to put the published period in there. So yeah, so I need to do that, right? So now what I'm doing is comparing March and April, basically say, okay, what's the absolute difference, right? You know, in the per day period, and what's the percent, right? How close are they, right? So because what I want to do, if you go to this page here, right? So what I want to do is like do a continuous time series over multiple months of imaging these guys, right? So we can actually look back here and get a more higher confidence, like, yeah, looks like the period on this guy really is changing, right, over this 6 or 12-month time period, right? So I think that would make a nice study. I think that could be some publishable results in a journal. And so, you know, I didn't put on here, you know, well, I said need continuous series. I think I requested twice a month for the CDK 24 scope. I don't know if that's possible or not, but that would be great to be able to have a long-term.
So what do you need? Like one night?
Yeah, just one night. I said twice a month. I was trying to spread out like every 2 weeks or something. I think actually, Leon, did I send you a calendar request or something? I thought maybe.
Yep, you sent an email to the targets email.
Target email. I think I had the actual dates. I went through the calendar and picked out like about every 2 weeks if we could get like one night of data, 30-second exposures, one night of data every 2 weeks.
Yeah, the issue is that it's pretty much set now. We can get, I think we've been getting 2 hours at the start of each night,
Okay.
but at this point it's almost not worth imaging. We'll have to wait.
Okay. Okay.
Yeah, or you can pick another star field that you like and start another project.
We could, right? Yeah, we could just go to another cluster or even an open cluster or whatever, and with that. So yeah.
Okay, that's great. I really enjoy seeing actual results pop out.
Yeah, I like working on this stuff. It's fun to pull out the curves and see how nice some of them turn out, you know, and then try to do some analysis. Yeah.
Okay, so to remind everybody, we've got the CDK 24 every other night continuously. How's that been working out? Who's taking care of that? Leon and Nick? How are we doing with that?
Basically, it's been cloudy.
Non-stop, 24 hours a day, clouds for I think 1.5 weeks straight now.
Yeah, it's terrible.
Mike's been complaining bitterly to me about that. There's nothing I can do about it, but it's fun to complain. Okay, well, anyway, when we get clear skies again, you know, we'll have it every other night. And I know Calais is interested in getting 29 transit observations, which is some special number, or we could shoot a few of our students and do a few less, you know, that would work too.
It's my number of students. Well, I'm going to hope to have some follow in Doug's footsteps in the spring when I do the research seminar again, and possibly analyzing the same Omega Centauri data, if possible. So that's amazing. But yeah, for exoplanets, what is the timeline for uploading those? I know it's always takes a bunch of bandwidth to get them someplace. But are they going to come to are they already on the are they on that new virtual server, all of them that have been taken so far, or are they still some of them to come there?
Yeah, I'll put them into the exoplanets folder, where you've been looking previously, so same place as always. But the problem is we just don't have any to upload because of the clouds. But when it wasn't cloudy, like 2 weeks ago, we were able to get 3 transits a night, because there are just so many targets which the CDK24 can observe. And I think that's a reasonable number. So I'd say on average 2.5 transits. So but half-light curves are okay, right?
Yeah, that's fine. Half-light curves, as long as they can see a dip, that'll be completely sufficient. But you were putting them before, and this is, sorry, apologies for getting back into the swing of things now that I'm back from my travels, but you were putting them on a virtual server that wasn't Google Drive before, right? Is that still the location where they will be, or are they going to the Google Drive folder?
That was Dale's private server. He
Right.
very generously hosted all of our overflow data on that. But we now have enough space on the Google Drive again, so we can keep uploading them there.
Oh, great. Okay, cool. So I'll just keep harassing you about that from time to time, maybe.
Yeah, well, the only problem would be if we leave them on there, because as soon as we turn that into a long-term storage, we'll run into problems again. But you can just move
Yeah,
them.
I'm gonna
to the
suck them
staff
down. I'm gonna suck them down as soon as you get them up there. So, yeah, if those 3 transits per night from 2 weeks ago, which is already making me salivate just thinking about that. If you could get those up there, then I'll suck them down right away, and you can liberate the space again.
All right. Leon, we can work out like an automated way to get these shuffled around. So if you want.
Yeah, Tom actually has he made a software for that already. For Mount Wilson specifically, we can it just copies from one directory into the Google Drive.
All right. Cool.
All right. Who else has topics for today? I have a major one, which has to do with darks, but anybody, Rick? What?
Yeah, I have. I just noticed a couple of days ago in the latest Sky and Telescope for October that there's going to be a kind of a unique opportunity to test Einstein's theory of relativity again. Something like they did early on in the 20th century for looking at stars that were displaced by the gravity of the sun during an eclipse.
Eddington's experiment, yeah.
Yeah. The note in Sky and Tel says that there's a website which is requesting observations of 3 stars in a row that Jupiter is going to come very close to. And they want astrometry so that they can see whether there's a displacement as predicted by the theory. And it also said kind of uniquely that before Einstein considered the sun as a source of curvature of space-time, he said Jupiter is a good candidate. And since I've never heard of that idea before, but this is a kind of a unique opportunity because these stars are close together and Jupiter's going to be very close to them in October. And it happens to be during full moon, and it happens to be pretty far south, so Chile is ideally located.
Sounds like you've got a project.
Yeah, it sounds like a good project for October.
Sounds like you've got a project, right? You should.
Well, me, I thought we could do it as a group.
What's the displacement, predicted displacement?
I don't know. I haven't looked at the website, but
okay,
there is one.
Yeah, that would be great. That would be.
I'll put the website link up on the chat when I can figure it out.
You want to tell us some more about that next week, Rick?
Well, okay, I'll look at it a little bit. I haven't had a chance this week, but
yeah.
Okay. Well,
okay.
Would Jupiter be too bright to see the stars, or?
Well, maybe Jupiter has to be out of the field. I'm not sure what the story is, how you do that. It's a set of 3 stars, and maybe the distance between them should show varying amounts of displacement. Maybe that's the deal. I don't know, but yeah, it would be kind of difficult. But I would think that speckle capability, like the 1 meter and the 24 have, and probably a good idea to do it with both telescopes, since it's just a one night, apparently just a few hours. That might be a unique capability that nobody else is going to have. The Sky Intel article says you need about half an arc second per pixel. And we've got, 0.2 on the 24 and 0.065 on the 1 meter. We can do much better resolution.
That sounds fascinating.
Yeah.
Yeah, and what are the
Wow.
brightness? I'm looking at the website that Calais found for us.
Oh, Clay found it good.
The I'm trying to read the introduction here real fast, scanning it. Well, probably not worth scanning, but
I think they're SAO stars, so they're probably pretty bright.
yeah, they would be 10th mag then and brighter. Anyway, that sounds like a really fun project. And we could, with a 1 meter, we could get very high, we get a lot of photons, so good signal to noise, and we could do very fast exposures, which will reduce and we can stack. And so there's lots of fun things to talk about. Why don't you tell us what we should do, Rick, next week, and we'll form a plan.
Okay, I'll look into it.
Russ.
Just two very fast things. The first one is just Leon wanted to let you know I'm working on some suggestions for the revised STB software, and I'll get them to you.
Great,
And
thanks.
Yeah, that's great that you're doing that. The other is, does anyone, I wanted to get Stefan Dross email. So he's been on this a couple times, and he said he was interested in working on an algorithm, and I lost his email address.
I can send it to you. Yeah, I'll send you the email address.
Okay, thanks, Nick. Do you know where he lives?
In Holland.
Okay, good. Okay, thank you.
Fairly close by, so.
Yeah, okay. I wasn't sure if he was a Pat student or Calais student. It's Nick's acquaintance in Holland. Okay, thank you.
Sure.
I've got one that I asked Joseph. Do you have that handy, Joseph? That one we were looking at yesterday, the speckle you did?
Yeah, I'll pull it up as we speak.
We had that discussion last week, the week before, about separation when they were really down to less than 0.2 of an arc second. And he's got a good example here from Mount Wilson that better than what we looked at before. Because this one's like at 0.15 arc seconds, so it was able to do a reasonably good separation.
Yeah, we have some below 1.5, even a little bit.
Really? Okay.
Yeah, so the closest separation successfully we had was 0.155, and it's this one here. I believe the topic we wanted to discuss was the dark diffraction ring, and just overall best practices in judgment.
This is
Okay.
the one we looked at before considerably.
So it looked like the bispectrum, this was bispectrum, right? Yeah, obviously.
That's correct.
So it looked like bispectrum phase reconstruction didn't work very well because the sideband is still there apparently. So we didn't remove the sideband and reconstruct the phase very well, but that's okay. You can still make measurements with that. So everybody know what I mean? You should, with bispectrum, after you run the reconstruction of the image phase, you should eliminate the sideband. The sideband is the thing that appears 180 degrees on the other side of the primary. Okay, so that didn't work. And you're sitting right in the middle of the first diffraction ring, apparently, which we calculated last week to be, I don't know, around 0.15 arc seconds. So, and what did you get for the measurement? You got
0.155.
Yeah. So you're probably trying to ask what you should make of this. What's the question here?
Actually, you just answered or alluded to one of our biggest questions was we are not getting rid of that 180 on any of our targets. So,
Hmm.
so yeah,
What are you using for your reference star?
just the standard reference stars that we took. So we took a reference star on this night for every single star.
And have you looked at the images themselves to make sure they're not saturated and so forth?
Yeah.
Everything looks okay?
Yeah, and every single star that we did, such as these, failed to get rid of the 180.
Okay, well let's see how you're running the program to make sure we.
Yeah, I
So-
could do a really fast one if you like.
Yeah, actually do it in real time. We'll take a look.
So I've already done all the bispectrum processing.
Right.
So we'll go to phase reconstruction. And let's do that exact star that we originally brought up. So that is 3804. So 3804. Remove photon bias. We calculated this with plate salt. We'll browse for our reference star. 3804 reference bispectrum. And we'll do Bax enhancement around 60 to start and low pass around 90.
You know, you've got autocorrelation only checked, so you got to uncheck that first.
Oh, okay. Is there a general rule on how long you let it run for?
No,
Okay.
sorry, until the error function stops decreasing. So there
Was-
you've got
So
a
that's-
reason.
Yeah, it was the autocorrelation.
I think that's the only, yeah, that was the problem. Yeah.
Well, yeah, there's a beautiful example of good bispectrum reduction, I would say.
Yeah, yeah, that's fantastic.
Well, you solved the mystery.
Okay, good. We can move on.
Very good. Thank you,
So
Dave.
can you, while you're there, why don't you do a measurement for us in real time? So bring
Yeah.
up yeah.
Dave, is there any guideline on that max enhancement parameter?
I can tell you what it does, but I don't have any serious guide. I don't have any high confidence guideline, but what I use is around 100 to 300. What it does is there are places in the spectrum where you have a zero. So this has to do with deconvolution. So the star's area function is going to have a zero at the first null in the area function, right? We don't want to, and we're dividing by that. So we don't want to divide by zero. So I make sure that we don't divide by zero. And what it does is it eliminates some of the ability to do perfect deconvolution in favor of not getting into numerical trouble. I don't know if that made any sense or not. So I would use anywhere, you can try different amounts of that. It shouldn't change the astrometry or the photometry very much.
And you say 100 to 200 is where you normally?
Yeah, I work anywhere from 50 to 500 just
Oh.
to see. I've done lots of experiments. This would be a good example to try different numbers.
Yeah.
Okay, so what did you get? You got
0.16.
yep, and with a differential magnitude of 0.33. Beautiful. And that's in R band. Well, actually, it's in I band, right? Your center wavelength is 760 nanometers. That's infrared.
Yeah, this is your filter, Dave.
This is my filter, right? Okay, that's the that's the ProPlanet 80 ProPlanet whatever it is. What is it? 700 and
742.
yeah, 742. I think yeah. Okay, so that's beautiful. I think you showed us that that's a really nice result from Mount Wilson. Great telescope to use for this.
One thing I suggest is to the way I like to do it is to shorten that relaxation parameter or shrink it down so that the convergence takes longer. I like to watch it happen.
Yeah.
When it's a large number like 1, it just goes to the solution and pretty much stops. But
Yeah.
if it's like 0.1, you can watch it get closer, and you can watch the one sideband disappear slowly, and it's kind of fun.
That's
Oh,
useful
that's
too.
great. That's really good advice, Rick.
Great.
That's a remarkably beautiful example from the 60-inch telescope, because it's
It is.
Look at where it's first diffraction. You're sitting right on the first
No, sitting
diffraction
right on
range.
it.
So
Yeah.
very beautiful. That's a winner. That's like the Mona Lisa of
Yeah, it really is.
not
Yeah,
that I like
actually, I've seen a lot of really good images coming out of the Mount Wilson week. I mean, we've got some really good ones like this with the diffraction rings, very observable. So it's very exciting.
Cool.
Okay.
All right.
That's
Perfect.
beautiful.
Yeah. Well, thanks, Joseph. That was like we all learned from that one a bit here. Thank you.
Yeah, thanks everybody. Thanks for clarifying things, Dave.
You're welcome. So,
Hey, Dave.
yeah.
Before we go on, I have a little problem that I ran into in processing some of our images. There's, if I can share my screen, I'll show you an error message, and that accompanies another error message that I don't show. Let's see if I can share the screen here. There you have it. The message that the other message is that the K-space radius is less than 5, and that kind of stops the processing of a few of these. And I also noticed that sometimes when I would, I'm not so certain of what I saw, but it may be that on occasion I went back and the same error message did not appear. But I mean, this error message we see frequently, and usually when you continue it, things work all right. But when we get this message, and then there's this other second message, which I didn't have a picture of, which is that the K-space radius is less than 5, then it fails.
Okay, well, let's try to work our way through this. I can't actually read that error message because it's too small on my screen. Sorry.
The remove photon bias box is not checked. That's a problem right there.
If you click, okay, the process it can't access the file. Okay, so it can't find some file that you're looking for. Okay. And when you do so there's a couple of things already. When you do bispectrum processing, when you use this window, you actually have to use a reference star. That's a error.
Right. Right. This
in the GUI.
That is how it was recorded. I did check both remove photon bias and use the reference star, and there was a reference star in there. This one doesn't really. Maybe the other one. Hang on just a second. Yeah, this is more representative. Oh, no, I'm sorry. This one was successful, obviously.
So what I suggest you do, Scott, is when you run across this again, you're going to have to take screenshots along the way that shows exactly where you're at.
Yeah, I'm sorry that that I don't have a good recording of what went on, but I certainly did have remove photon bias checked, and there was a reference that isn't representative, I don't think, of the error that we see here. So I will go back and document it better, and then maybe we can have another chat about it.
Okay, good. Yeah, thanks for bringing that up. We'll continue to, now that we have the young guys working on the problem, maybe we can solve some of these issues with
yeah, right.
Okay.
Sorry,
Anybody-
sorry, the explanation was incomplete, but it's been a couple of days since I did it. I'll go back. I'll straighten it out.
Okay. Anybody else have something they'd like to bring up? If not, then let me move on to an interesting discussion about cameras, noise performance, darks, and so forth. So,
Cool.
Pat, so Pat has a telescope at SRO called Baron, and it has a QHY 6. It has a QHY 600 camera on it, and about, I don't know, a few months ago, Pat and Grady showed me some images, and that they didn't like, that weren't working well, and I took a look and I found that the background noise was very high compared with what I expected it to be. And so we've been trying to figure out what's going on. And so Pat did some darks for us to take a look at various binning of 1 and binning of 2, and then various time exposures of 5 seconds to like 120 seconds. So and then he zipped them up and put them on Google Drive, and I got them down, and I've been taking a look at them this morning. And so I want to talk about that, because I know Dale is very kind of an expert in these cameras. So I just want to point out what I'm seeing. So let's take a look.
I apologize. I saw the email and I haven't had time to take a look at the darks myself yet, but I can fire that up right now since I'm
So you should
all along.
You should see my plate solve window. Do you?
Yep.
Okay, good. So I'm going to open, first of all, let's open so here's the downloads. Here's what I got. I'm looking at bin 2. It turns out it doesn't matter. Bin 1 and bin 2 doesn't matter for this discussion at all, as far as I can tell. So let's look at the 120-second darks first. There's 10 of them here. And I made a master dark, which I'll talk about in a second. But let's look at one of the raw darks, so to speak. Okay, and there's the full frame. And if I amp it up a bit, then you can see that there's a lot of odd stuff that I'm uncomfortable with. Were these darks taken during the day, Pat?
I didn't do them. Grady did them. I don't believe they're in the day. I think they're in the evening. I think it was dark, but I can't swear to that.
And it was with the obscure filter.
Yeah.
Right. Okay. So either there's a light leak or the camera is performing in some kind of odd way. I imagine this is a light leak.
That has all the hallmarks of a light leak. The gradient.
I wouldn't be surprised, because I wouldn't be surprised. I think there's good possibility that. Yeah.
Okay, so my guess is that you took these during the day and there's a light leak, but you have to go figure that out.
Okay.
But anyway,
how are you taking darks during the day? Are you having them cap?
I've not been doing it. Grady's been doing. Sorry, he's not on the call here.
Okay.
He's in Korea or flying someplace.
I see. I see.
Well, in Chile, if I use the dark filter but I don't close the shutters, I get the exact same result as what you're seeing.
Yeah.
Yeah. Okay. So we may have a problem with the filter wheel. Really isn't a chamber that's completely black, so to speak. So
it's not. The test for this would be to call up SRO and get them to take some like aluminum foil and wrap it around the where the focuser draw tube meets the filter wheel, and make sure and tape it down with like blue painter's tape. Okay. And the aluminum foil acts as a pretty good guarantee that no light will get in, because it's aluminum foil, not fabric.
Right.
And you can use that as a test to see if you get this kind of light leak. You want to, of course, take those darks under the same conditions in which these were taken in order to try to induce the same problem. And then they can just take the foil off and take your darks again. And if you see this kind of gradient again, then you've pretty much nailed down the fact that it's a light leak somewhere in the imaging train.
Right.
And unfortunately, this stuff happens. Imaging trains are, it's threaded components. And sometimes they're bolt on with flanges and there's leaks between the flanges and stuff like that, especially the QHY stuff. The QHY stuff does use flanges so that there is a chance, a non-zero chance, that light can leak in through where the flanges join, for example, the filter wheel body. Or there is this QHY 600 has I don't have mine here with me, but a device called a CTU, or centering tilt adapter, that the camera sockets into on the back of the filter wheel. And this is not a light sealed attachment point. So if I had to guess, given how well defined the gradient is here on this image, I'm going to guess that the light leak is happening close to the sensor, and that CTU is the prime suspect there.
Yeah.
Okay.
So,
Good.
so
Well-
I would have them put aluminum foil around that area. Be sure not to, of course, block the exit ports for the thermoelectric cooler and the air. But and seal that up pretty well with some painter's tape, and see what you get as a result.
Okay.
Great advice, Dale.
Yeah.
So we have to solve that problem, but there's a deeper mystery involved in this camera than that. So I think that I can proceed with this analysis, even though there's a light leak in the camera, because I don't think that light leak is going to obscure the fact that we have a noisy camera also. So what I'm going to do is, since Pat sent 10 of these, I'm going to make a master dark using the 10. So I just average it. And in PlateSolve, if you want to watch that happen, you just go to combine images, select the images you want to combine, take the average of. So that's what I did. I selected those, and it goes really fast. So then you hit average. You don't want a sigma clip for making darks typically, although you can. We could talk about what that means. That'll reject cosmic rays if you've got a lot of cosmic ray problems, but I just did an average. And so let me bring up the average dark. There's what I call the master dark. Okay. And you can see that, I don't know if you can see, but it's much lower noise. I can see that. So this is the average of the 10 darks, but you can still see the light gradient. So there's the gradient, and we can go exploring what the background looks like. Now, so here's the first interesting thing. The background mean is about, you look over here, there's the mean and the standard deviation of the background. And you notice I've got the aperture set so that it's almost all background. There's no
Right.
Signal part of it. Okay, so the mean's around 5,800 and the standard deviation is very high. It's 741. Now, these are in not in photoelectrons, but in ADUs. But an ADU is close to one photoelectron for this camera. Okay, so very, very high standard deviation of the background. Another way to show that is to take the histogram. And the histogram is very interesting and pretty ugly. So this is plotting linear. So this is the number of occurrences per histogram bin. And this is the value of the pixel value. And I'm sure you guys all know how to read a histogram. So I can.
Is that the whole image or just the
This is the
aperture?
whole, yeah, this is the whole image.
Yeah, that should be a pretty rounded
Yeah, and the reason it's not rounded is we've got a bunch of light leak, and you can see the different places where the light leak is different. You know, there's that bright corner and so forth. So with this, it's hard to figure out what we've got in terms of noise. However, what I'm going to do is I'm going to take one of these and dark subtract it. So if I go to process and dark subtract, and then what I do is I browse to the image I want. So I pick any one of these 120-second images, right? I can pick any one of them. And then sorry, it's asking for the dark. So I pick up the dark, that's the dark, and now I select the image I want to dark subtract, and I could pick up any one of them, but I did them all here. Okay, so there they are. So I won't bore you with the process. It goes very fast, but it's not necessary here. So I'm going to open one of the dark subtracted images. So in dark subtract, there's each one of the images dark subtracted with the master that I just created. Okay. Boom. Now look at how much better that field is. Of course, we got rid of the light leak problem because we're, you know, subtracting the master dark from each one of from the dark. So we got rid of the light leak, which we're supposed to do, but we also killed off a whole bunch of those hot pixels, right? In fact, we killed off every one of those hot pixels except for a few guys like this that might have been a cosmic ray hit. Hard to know what that is. Now, if I look at the histogram, I get a much prettier picture. This is what a histogram is supposed to look like for noise. Now, this again is on a linear scale, but if I put it on a log scale, I get the beautiful inverted parabola, right? And so this is that second order. When I take the log of a Gaussian, I'm supposed to get a parabola. Okay, sorry, if you take a parabola and you exponentiate it, that's a Gaussian. And so I've taken the log of it, so I should get back the parabola. And I do. That's quite beautiful in terms of showing a very noise-like Gaussian histogram. So I'm quite happy with that. And then we can read off we could directly read off from this. Actually, it's easier with linear. We can directly read off the standard deviation of that Gaussian, or we can from the histogram, or we can get it another way, which is by just using my tool. Okay, so this is dark subtracted. Yeah. So the standard deviation is around 135, 140 ADUs. And because we only have 10 darks that are in the master dark, there's a small contribution from the noise there. So, but it's, you know, theoretically only 1%. So anyway, let's take 135 ADUs as the background noise. Now, QHY cameras advertise that their noise is going to be like 1 or 2 photoelectrons. And since there's about 1 photoelectron per ADU, the number here should be in the region of, you know, no more than a few ADUs of standard deviation. So again, I conclude, as I did last time, that there's something wrong with this camera. It's very noisy, and it's either the settings that we're using or the camera itself is just super noisy.
Okay.
And so I'd like Dale to have a look at the camera settings.
Okay.
That you guys are using, and make sure we've got everything set up properly with that camera. But I think the camera is just noisy. And if so, we have to decide what to do with it.
Okay. This is a quite interesting way to analyze it. This helps narrow it down, I guess. So you're thinking the standard deviation should be under 10 at least, right?
Yeah. certainly
Pat, do you
understand.
know what temperature it's cooled to?
It's -10°C, yeah.
We can go look at, let me go back and open up one of the original images.
But since I don't even know the time of day when it was done and so forth, we really need to have Grady, we should set up a time, Dale, that works for you and fits Brady's flight schedule.
I'm looking at the image headers right now. Oh yeah, okay, you have it up in your screen. I have mine open in PixInsight. The readout mode here is normal. So what this tells me, what software was used to capture this? Looks like it was.
Well, let me see. Good
Look,
question. What was used to capture
Interestingly,
these?
the pixel width and height are completely wrong in microns. Or is that after binning?
Well, this is a bin by 2, so I think that's correct.
Yeah, the pixel size is multiplied by the
Oh,
bin.
right, that's after
Yeah,
binning. Okay.
that's correct.
This is a super pixel, right?
But what we lose here, they're using and whatever software they're using, this isn't the, it's what?
Maxime.
Maxim, okay. So it's using the ASCOM driver. It doesn't have a native driver for QHY cameras. So the readout mode here is normal, which is unfortunately for the QHY ASCOM driver, it doesn't tell you the actual it doesn't tell you what normal means in terms of readout mode. So we don't know if you're running in the extended full well mode, which is the low conversion gain domain of the sensor, deeper well, higher noise, or the high conversion gain domain of the sensor, which is what we run on the Chile scopes, which is a shallower well, but with that 1 electron read noise. So it could be, depending on the settings of the ASCOM driver here, you might be running in the extended full well mode, which is mode 0, I believe. And you would, if it's running with default, it'll be running at mode 0. We would just need to check that out in the configuration with the screen share or something like that.
So it does say the gain is 60, which I think is in the low noise region of the operating parameter.
No, the gain actually is specific. The gain scale is specific to each readout mode. So a gain of 60 here doesn't bump you, like with ZWO cameras. You bump up into you cross the threshold between the domains by what gain level you set. So a gain level of 0 to 99 is low conversion gain. A gain level of 100 and up is high conversion gain. On the QHYs, it's different. It's the whole gain range applies to the operating mode of the camera, and the operating mode of the camera is tied to the gain conversion domain of the camera that you have it set to.
Right.
So this may be a case of a gain that's appropriate for the high conversion gain readout mode, but it's maybe being used in the low conversion gain readout mode. And also the offset's a little high. But again, we won't know the full story until we can get on the system and just open up that QHY driver's configuration and look at what it's actually set to.
Right. And I don't like Maxim DL for these digital cameras, so I think we should be using some other software to capture the images.
There's the hang up because it's run under ACP, and ACP requires Maxim.
Yeah.
Well,
we can straighten this out with Maxim. It's a little bit more laborious, and we don't enjoy the rich metadata that we get with direct our native driver imaging apps like Nina in the header here. But we can check this out and bend it to our will.
Good.
Okay.
So
do you have a bias for comparison?
I don't have it. No, I don't have it handy.
But I can open up the 5-second. I did the same analysis with the 5-second, so you can see what the differences are. I want you to also notice the vast improvement in the calibrated images, just calibrated with the dark frame, because all of this, what looks like hot pixel stuff, it all goes away. And it gives us a really excellent background. So if you want high quality science out of these cameras, you're going to have to dark subtract. I know I've been hammering you guys about that, but if you don't, you're losing a lot in what you can do with our telescopes and cameras. So let me open. So I don't know how to show this exactly. Look at the very large standard deviation I'm seeing in this image. Again, this is a bin by 2, 122nd. Notice that the standard, remember that after dark subtraction, the standard deviation was around 130 or 135. Now look what it is for a raw image before it's dark subtracted. It's really huge because there's so many hot pixels.
Right.
And there's another way we can goof around with the black and white levels to show the same thing. That might be useful just to show you some of the tricks you have available. So if I ramp up the black level, a nice thing to do is ramp up the black level and then ramp down the white level so that now you're really, you want to be about there. Sorry, I've got the histogram in the way, but now you're looking at all the junk in the image.
Oh,
Okay,
boy.
and there's just a huge amount of junk.
Yeah.
And you can also see the pattern noise in this
Yeah.
case. So if you go back to that view, I don't know if you can bring it back, but
Sure, we can goof around with this.
the pattern noise is what a bias would knock out. A bias would knock out the hot pixels, and what you see there is the pattern noise, that like effect there. This goes back to a discussion I think we touched on in a previous meeting about auto calibrating the images we take off the telescopes, right? So that the PIs don't have to worry about keeping a library of darks and making sure that it's up to date, because you periodically have to update the dark libraries because sensors age. I think what would be best is in this case, is that we start noodling on ways to auto calibrate frames as they come off the camera. And that's something in general that I like to do for Nina anyway, because it's just useful, and it takes a lot of, an imaging computer does a lot of nothing in between frames, and it can be doing things like calibration after a frame is taken off the camera. So maybe this is
background. We do calibration every month and update them, and then all the files that we use or distribute are already calibrated. So,
sure, and we would, so an arrangement like that would be, I think, optimal. Excuse me, optimal here. So we just need the machinery and the app to, when a new image comes in, apply a designated master dark to it. And there's also there's dark subtraction, but there's also flat fielding as well. That's been talked about, and flat fielding is a little bit trickier because you have to acquire the flats. Well, how do you acquire the flats? Sky flats.
We have a light panel and all that, and we do that, like I say, monthly. We have to.
Yeah. So. Right. And so you can automate that easily. And we can look at how to automate sky flats for the 1 meter and 24 in Chile. And so that that process becomes two-step. We pull an image off the camera. As it goes on to image, the next image, the exposure, the previous one is being calibrated with a dark subtraction and a flat field. So
okay, so I think there's 3 takeaways here. One is that I think this camera has a problem, or the settings are inappropriate for its use, or
Yeah.
Maxim's doing something along the way that we don't like. We have to dark subtract. We have to at least dark subtract, I think, to do high quality science with these.
Right.
I think we're losing a lot. I know we're losing a lot, because if I take the Fourier transform of this, each one of these guys is going to act as a point source of noise that gets then spread over the Fourier transform. If you take a delta function, take the Fourier transform, you get a uniform field, and that's just adding to the background during speckle. So that's bad. And there's light leaks here that we have to be really careful of,
Yep.
you know. And so I think all of those things are things we need to further beat on as we go down the road here.
Thank you. Yeah,
Enough
I
said
agree.
about that.
Thank
Still,
you. We do
the
calibrate
standard
all.
deviation-
We don't work with anything but fully calibrated images, but
Yeah, but in speckle we do. So
yeah, that's the problem. I wanted to ask you about that. And it's the second question I want to ask about binning too, but yeah, how would you go about it with speckle?
well, you've got to make a master dark, and you've got to calibrate each one of the speckle images before it's run through the Fourier transform process,
Okay.
before it's run through speckle toolbox to
Okay.
reduce it. Because if all of our cameras are behaving as bad as that one, and I don't think they actually are, but that would be a real disaster. We'd be losing a huge amount of SNR.
Okay.
I think this is a bad camera, so we don't want to generalize too
Mhm.
much from
Yeah,
that.
those standard deviation values don't line up what I've seen in 5 other QHY 600s.
Right.
Even with those settings, even if you're in the worst possible readout mode and you're in front of the noise clip, you still shouldn't be having those levels of noise.
I agree
I
completely.
mean, even of course, accounting for the offset, just looking at the standard deviation, that's way too high.
Exactly. Nonetheless, I think we should, make a big effort to dark subtract
Sure.
our
There was,
speckle.
I think Dale mentioned a few weeks back about the problem with binning with the QHY, and that the software did not, you didn't gain anything through binning, as I recall.
The bidding is because the CMOS bidding is done in software. It's not hardware pixel bidding. Just due to the architectural differences between CMOS sensors and CCDs. So it's a additive binning rather than an averaged binning. Although there is a mode that produces averaged binned output, it requires us to extend the internals of the imaging app to we store things as 16-bit imagers in the imaging app. The output rule require us to store also 32-bit data types, 32 bits per values per pixel. Because in computer terms, there's no, you don't have a 20-bit data type. You don't have an 18-bit data type. It's 8, 16, 32. So the next largest data type is the 32-bit integer. This creates monstrously large files. 32 bits per pixel times however many pixels your camera has. And so, but then again, these are binned, so that actually gets reduced. These aren't 32-bit pixels. 60 million of them. They're going to be 30 million of them, or no, a quarter of that, 20 million of them. So it's or 15, but that's a bigger issue. And if you the only real reason to bin is to get brightness, but and lower your exposure time because it's additive. But and the other reason to bin on CMOS is to reduce your file size if that's a concern or something like that. So that's a bigger discussion and a lot larger lift to do to get. But I think auto calibration would be the first hit that would benefit everybody in terms of the Chile scopes, at least. and the data coming off of those.
Okay.
For speckle dark subtraction, we've talked about that a little bit before, but when we're using region of interest, which is a different group of pixels for every star, basically, we have to be really careful about how we dark subtract. And what I've tended to do is to try to take a new set of darks for every new star.
It's convenient that way because most calibration tools do not account for ROI images, right? So
yeah, that's a difficulty that we have to deal with.
Right. What we would need is a tool that can take an ROI'd image, or 512 by 512 pixels images, and take the master dark for that sensor, which is going to be 6,000 by 4,000 some odd pixels, and cookie cutter out the correct area of that image and that master dark, and use that shape to calibrate the light frame, right? So
we've talked about doing that, but I don't think there's any way to set it up quite yet, is there?
no, it's just not a feature you find in image calibration out there, and because most people don't ROI image like this, I guess, right? They use the full real estate of their frame, and they're going to calibrate the full real estate of their frame.
Yeah.
The only other thing that's approximate to this is our overscan areas on the side of images, but those aren't applicable in this case. Yeah, so any live calibration tool that we invent would obviously have to account for ROI and how it would have to extract that region from the master dark and then apply it to the ROI'd image, and then you'd be off, you're fine.
Yeah, the fit header for the ROI images does include at least the corner point reference in the full frame, right? So it's possible to locate it.
Right, yeah. And in pixels X and Y, whatever pixels Y, and there's your origin pixel, and cut out from there, right? So that would be a fun extension of this auto calibration tool. So maybe it's time to start seriously noodling on that kind of plugin for Nina and come up with a prototype.
In the meantime, taking the darks in each ROI for each target is the only way to actually use dark subtraction.
And it's kind of a waste of time, and I mean,
waste of time, and it takes time in data reduction too. But I usually use multiple filters, so it's just one extra filter for me, which is not too long.
Right.
Well, it's not a waste of time if it greatly improves the science.
And also, you only have to run off. You don't have to run off the full sequence.
No, I've been using 20 frames.
Yeah,
instead of 1,000.
20 frames gets you down less than 1% effect of the noise.
Right.
So,
but you got to go through, if you've done 50 targets in a night, you got to do 50 dark subtraction.
And maybe 50 for the reference, but that's probably not as important.
It's going to be the reference too. So that's pretty tedious.
Yeah, that's a lot of time. That's many minutes.
Yes.
Doing administrivia basically rather than collecting data.
Yeah. I mean, certainly capture the darks, but then doing the rest of it.
Certainly, the software in STB could be easily set up if you knew where to look for the darks. Your obscure filter, you just average it and subtract it. If you've done, then you don't have to worry about the ROI, as Rick pointed out. If you just take that, leave the ROI the same when you do your dark.
Yeah.
Okay. Anyway, it's something to think about, to worry about. I don't know how bad. I still don't know how bad our cameras, the good cameras, are relative to these warm pixels and other effects. We should look into that too.
Maybe take a look at the ones in the Chile, just see how they stack up. But meanwhile, I'd like to see if there's a time. What's the best way, Dale, for you to take a look at what we've got so you can get your.
Generally after work hours, US East Coast time.
Okay, all right.
So
Let me get Grady on here because he's the one, particularly when you start talking about ACP and so forth. I don't have a clue on that and where that impacts it.
Right. Okay. ACP wouldn't be involved in this. ACP is just a scheduler. It fires off Maxim DL to do the actual acquisition work.
That's what I'm talking about. Is
yeah.
Requires
So,
Maxim. Yeah.
So Maxim, we'll open up Maxim DL and take a look at the QHY driver settings and make sure that those are
okay.
What we expect them to be.
Okay. And then once we figure that out, then we can decide whether this camera needs to be replaced or not. I guess.
True. Yeah.
And meanwhile, we've got to track down the light leak.
Yeah, that's the other task. Yeah.
Yeah, but to do good darks during the day, but if you do darks during the night, usually you don't have the light leak problem.
Yeah, shouldn't be a problem.
Okay.
All right, thank you.
I'm gonna leave because I have to make lunch today. my famous fish curry. So.
Excellent.
Take care, guys. Bye-bye.
All right, thank you, Dave. Yeah. Bye, Dave. I was going to ask, what's the next time frame for the 1 meter for August? When does that start? At the end of the month?
Yeah, probably at the end of the month, but we haven't had an actual date yet.
Okay.
For the 24, we have that every other night, but it's cloudy, so.
Okay.
I'll do anything when it's cloudy.
We check in the afternoon here on the East Coast, and it's cloudy, and then I check before bed, usually around midnight, and yeah, it's cloudy. So it's sometimes it clears up in the very early morning hours before daybreak, but it's like no one's awake to take advantage of anything there. So
I never think of that area of the world being cloudy, but apparently, or maybe it's just the whole world. I don't know. We're certainly cloudy here.
It seems like they have a kind of a marine layer issue, sort of like the west coast of the US. And maybe it's just a thicker marine layer in the winter when it's cooler.
Yeah.
I've been seeing reports of just abnormal weather in Chile right now in general. So
if you look on the satellite map, there's a big storm coming in from the south.
Oh.
Yeah. It's Pacific hurricane season. We have Hurricane Hillary, I think, off the coast of Mexico, moving north.
Yeah, we're about to be have a hurricane in Southern California.
Yeah, you were not. I was mentioning at the beginning. This is the first time we've had a tropical storm watch in the history of Southern California, which is
no kidding.
First time since 1939, I heard.
Oh, was it 39? I didn't hear that. Okay, so 39.
It hammered San Diego and Long Beach pretty badly.
Did it? Yeah.
Pull in your patio furniture and
yeah, thanks for reminding me. Yeah, my wife wants me to get the gas for the generator and everything else. So I'm gonna be running around. I'm not going to put any plywood on the windows though. I don't think we're going to go quite that far. I don't.
No, tropical storms aren't that bad, but yeah, pull in all your loose stuff outside and stick it in the garage or whatever.
Yeah, good point.
They're predicting 7 to 10 inches of rain up at Big Bear.
Yeah, that's what I'm thinking. Our observatory is it's going to wash it away. Yeah,
it's a Southern California. If it's not fires, it's mudslides.
Yeah, exactly. Okay. Anything else, guys?
Yeah, all this time I've been looking at the camera on the CDK24, and the standard deviation in the background there is significantly lower, less than 1/10 of what Dave showed, though it varies too.
So it was like 130 some, as I recall, on the dark subtracted.
Yeah, I'm seeing a 9 right here.
Okay, so like I was saying,
some to 5 occasionally, depends on how I drag the aperture. But this is in another readout mode, but as said, I'd QHY back then for ExoClock. I had their entire lineup of all cameras, and cycling through the settings there, I assure you that I don't know of any settings which could cause the levels you're seeing.
Mm-hmm.
I don't think I forgot. I was thinking if I maybe mistaken due to this high offset, but that does not have any effect that I can think of, any residual effect.
What should be the setting, the mode and the gain?
For speckle, it should be high gain mode with a gain setting of just above 55, so 60. I think unity gain in that gain readout mode, if I remember correctly, is 25, but that doesn't matter. But that would be a reference for how to multiply to, yeah. And the offset you can leave at around 30 then. The only consideration is that, as opposed to Dale, I've never worked with the readout mode normal. I don't know what it's doing there. All our testing back then was using Nina, SharpCap, and I don't know what the ASCOM driver sets as normal.
The QHY ASCOM driver leaves some things to be desired when it comes to readout mode management. And yeah, normal as what the driver announces does not correlate with the actual mode the camera's running in. As far as what I remember is that the QHY driver will say normal for regardless of what mode you're running in to the app, and that's what's recorded in the FITS headers. However, the readout mode is a separate configuration item within the ASCOM driver, and you have to go in and make sure that the right one's selected.
Okay.
It's really strange. And I remember I don't have my QHY 600 up here in my office with me because it's on my telescope downstairs, but I do have a smaller version of things of it. And don't mind my messy office here, but the back of the the front of the QHY camera. Oh,
I've got to run. See you all later.
See you, Russ.
Bye.
Hey, boys. The front of the QHY camera has the circular dovetail,
Mm-hmm. Yeah.
and it fits into the back of the filter wheel into an attachment like this, and then you use these thumb screws to screw in and push against that circular dovetail.
Right.
The QHY calls it a centering tilt adapter, this part right here, but it doesn't really does anything for tilt, and it certainly is a pain to use for centering. So what happens is when the camera sockets into this like that, and you crank these down, there's this seam right here that quite often, I'm sorry, there's a seam right here. You can probably see it in the camera, in the video, that quite often prevents a full light seal from happening.
Yeah.
So given the definition of that gradient, it's not very blurred. It doesn't look distant. It's close to the sensor. So my guess is that light is coming in right here through this joint, and it could very well be coming in other places on the imaging train forward of the filter wheel. However, this is given the definition of that gradient. That's where I would direct SRO staff to do the aluminum foil test.
Right.
Yeah, two questions on that note. Where is your Barlow located? Since I saw you were using one, and are you using the tilt adapter which was machined down?
That is just the Barlow. When you're talking in the those images were taken without the Barlow, but the Barlow configuration is very unusual, especially machined, and I'll have to get you some pictures of that. I'll have to show you some pictures of these.
Yeah, but where is it along the imaging train? Like in inches from the camera?
It's attached to the camera, so
direct in front of or behind of the filter wheel?
Behind the filter wheel.
And is the tilt adapter the one Joseph had?
I'm saying that I have to look at the pictures because I haven't been there physically when they've installed it, so I have to pull out the pictures.
It could very well be the Barlow that, since you have a special, that would be the primary suspect in this location if it's directly after the filter wheel.
Yeah, but this was taken without the Barlow.
Oh,
Yeah.
all right.
These were taken just without a Barlow. Yeah.
Oh.
No, no question that a light leak could be possible here. And so I definitely need to.
It does have that same exact mount, though. That's the only type of interfacing mount for the QHY 600.
Right. Yeah,
Right.
that CT. Yeah, they'll arm themselves with a roll of aluminum foil and a roll of painter's tape and go forward and
Yeah. And
cover
just
things up.
and just if you can't fix it any other way, just do it that way every time you attach it.
Yeah. I mean, the only impingement it causes is when you're doing darks in the daytime, right?
Yeah.
So, I mean, you have to weigh your things, you have to weigh your
Yeah.
cost benefits there. Like, do you want this aluminum foil wrapped camera and imaging train all the time because you want to do lights in the darks in the daytime, or
Right.
do you just do them in the nighttime?
Yeah. Understood.
So, assuming that the environment, that the imaging bay there at SRO doesn't have any bad neighbors and spewing light anywhere, you know, that kind of thing.
Yeah, I think it's pretty good. I mean, the people there
Yeah.
are pretty professional. They don't.
Yeah, there's pretty strict rules in place about light emission there.
Right. Okay.
Obstack uses painter's tape, and I use electrical tape around the entire thing too, which is also useful for ever detaching the spacers, the threaded ones. Electrical tape, just tape the rest together. And the other tip is close the shutter, even though that light leak is very defined. I know the QHY filter wheel, if you have a dark filter in there, it does not block the
It's a starlight. It's a starlight filter wheel. It's not a QHY.
Oh, is it one of those big maxi ones with like
Yeah.
the 20 slots or whatever?
No, it's only got 10 slots.
Oh, okay.
Yeah.
Yeah, I know they make a big, like, size of a pizza filter wheel that.
Yeah, no, it's not that. No. But it may have the same attachment problems that you have with the QHY.
Yeah.
Yeah, that's another unique attachment in that case.
Yeah.
But I still don't see how that would cause such a difference in the standard deviation.
No.
But for now, that's the only unique factor I can see. I mean, definitely double check the camera settings with Dale.
Yeah.
But I don't see why any of those would be the cause of this. I would, well, you could also ask them to put the cap on the QHY camera just to nail down the problem and make sure it's definitely not any outside influence.
Mm-hmm.
I wouldn't know why that would increase the standard deviation at all, but
yeah,
it's worth doing before you send the camera somewhere.
And we're looking at bin 2x2. There's no reason that would affect the readings we're getting. 1x1 would it get the same, I assume, or similar?
It would be the same. Yeah, the binning is done in software. So it's taking a normal bin 1 frame and in software making it a bin 2.
Right.
So it's actually using the same source, the full frame.
Okay.
So Rick, did you have a question or?
Just a couple of comments. The camera we're using at Mount Wilson was the ZWO camera 6200, I guess it is.
That's their analog of this.
Yeah, and it uses the same chip as the QHY, but it's a front interface is a threaded 54 millimeter, I think, T thread.
Okay. Yeah.
And so everything in the train is threaded,
Mm-hmm.
and the filter, we didn't use a filter wheel because we didn't have one with 2-inch filters or bigger. So we just threaded a single filter into the front end of the 2-inch focuser that went into the telescope. So there hasn't been, as far as I know, any light leak issues with that system. Although I don't think we've ever studied it either. In detail, anyway. And the other issue was, Dave showed the darks with what looked like lots of hot pixels, and then he squashed down the range to bring up lots more pixels, which I guess are the so-called warmer pixels. It seems to me there may be 1,000 or so hot pixels in that image. But when you consider that there's 62 million pixels in that camera, that's a pretty small percentage. I think that's a really good quality camera because it's so huge.
That's a good point.
And
If
of
you
course-
looked at that kind of camera, 10 years ago, a CCD or anything, it would just be almost totally white by comparison.
Yeah, and you'd also
And-
have
and the-
like.
Yeah, I mean, they're great cameras, but this issue of noise is still a problem.
All right, well,
Okay.
once we check the settings and redo a batch of darks without this light leak, then we can fully assess with some certainty about the health of this sensor.
Yeah,
So-
hopefully all those problems will go away.
Do note that even though the standard deviation as a statistical term will be identical, of course the values will be different because I mean you're binning 4 pixels into one. So because Dave's software gives you the standard deviation in ADU counts, what you're looking at. So that will be proportional to how much you're binning by, of course. Just when you're looking at the images as a note.
So are you saying that the standard deviation should be divided by 4 because it's binned or not?
Yeah, 4, I think. Yeah.
2.
Yeah.
Okay. So that would, instead of 130, we'd be talking more like 30.
700 and
Oh, standard deviation was like 100. Well, okay. I'm sorry. Once those dark subtracted, it was 130.
yeah, for the 2x2s, yeah.
Yeah. So it would be more like.
Yeah, and exactly. And I was seeing significantly lower. Matt took some binned and unbinned darks all the way up to a few minutes, and I was looking at those just now, and the values there are much lower.
On the, okay.
As on the QHY 600, on the CDK 24.
And that was dark subtracted or not?
No, not dark, just the single darks.
Okay. Okay. And so you got what sort of standard deviation?
Well, I have to go back. This is in 1x1, it's between 5 and 9. So I guess in 2x2, multiply that by 4. So between, yeah.
Okay.
I'm trying to get something better than 5 and 9, but it's jumping around. It seems like the maximum background aperture is 200. I'd say between 20 and 30 in 2x2. Maybe.
And that's dark.
Roughly.
That's dark subtracted.
No, it's a single dark. Looking at the background of a single dark.
Oh, single dark. Okay. I'm sorry. Okay. Well, then, yeah, we're considerably off of that. Way off of that. Okay.
And I'm comparing the values Dave showed in the 5-second image to a 5-second image. Or, yeah, this is 1 second, but the 5-second one was the same. Yeah, because the standard deviation, that's why Dave was doing it in the background while we were talking on the screen. He was looking at the 5-second image and dragging the aperture around, and the standard deviation there was a little lower, but almost identical to what he showed in the 1/22nd, was it earlier?
Yeah, 120. Yeah.
Yeah, and that was almost the same.
And it was, you said it was like 750.
Not 750. 120.
Okay. All right. All right. Yeah.
What Dave showed. Yeah.
Yeah. Okay. So that's, yeah. So it's like 4 times or 5 times what it should be. Okay. All right. Well, Dale, you're amazing. What you guys are amazing. What's your knowledge of these cameras? That's incredible.
Oh, I'm not a formally trained scientist, so I'm always amazed by the work you guys do. So, my wife's a chemist. I live vicariously through her when it comes to science.
Well, I'll try to reach. I'll find out Grady's schedule here, and let's figure out a time that can. I think he's back in town this weekend. Do you have any time this weekend or not?
I certainly do.
Okay.
I'm not heading out of town, so
Okay. All right. I'm not entirely sure of his schedule. I don't stay on top of it.
Sure.
Yeah.
He's coming back from Asia. He's going to be half a day jet lagged anyway. So
Yeah. Oh yeah. He takes the first day off and he doesn't. He
Yeah.
just goes underground for that.
I used to work for Samsung, so I did the US to Korea trip.
Ooh.
And so
Uh-huh. Yeah. No, from
Not
the East
easy.
Coast, that's even worse. Yeah.
yeah, it is.
And one final thing before I forget is that the sensor in the ZWO would be an interesting comparison to test against these, because QHY's marketing says they have the better sensor because they have the K batch of the sensor, and apparently ZWO uses another batch. But they're not allowed. They're not really allowed to say if the sensor is better or not. They're not allowed to give any specifics about the sensor with their agreement with Sony, about what rejection this comes from, or in which forgot the word in which.
I actually asked Dr. Kui about this. Dr. Kui is the Q in
Yeah.
QHY.
Asked them too, yeah.
And he told me that it doesn't really have much to do with quality of the output. It has to do with the longevity of the sensor. In other words, the industrial grade sensors are made for constant operation and keeping within spec during that constant operation. So yes, it's better quality over time because it's designed to operate for a longer period of time.
Yep, and yeah, it's for 24/7. Yeah, but their marketing also says that the number of pixel defects is significantly lower.
Oh, okay, all right, maybe. And
so that would be an interesting comparison.
An A/B comparison would be good, especially if the cameras are made. It's impossible to tell, but especially if the cameras are made around the same time.
Okay.
But I know the ones in observatories like Chile and SRO and stuff like that, they're exercised on a weekly, if not almost nightly basis, right? Modulo clouds.
Right.
So,
Yeah. Ours, as long as there's no clouds, it's running. Yeah.
Right.
Yeah.
So
yeah, that because we're on ACP, it just sits there waiting for the roof to open up and it picks a target and runs without us paying attention.
So yeah, if Grady's around this weekend, then here let me put.
We'll do a couple alternatives and see what makes sense.
The best way to get in touch with me is just to text me.
Okay.
And
okay.
There's my number right there. So
Perfect.
you can just go ahead and drop a text to that number and add some context to your message. So I don't think it's like, are you available? I don't know who this is.
Another spam.
And yeah, there you go.
Yeah. Is it for what you want to do? Does it matter if it's day or night?
Doesn't matter. We're just going to look at settings.
Yeah. Okay. Fair enough. Sounds good. We can probably work out something then. All right. I think it's over an hour and a half now, so I think it's probably time to call. Hank, thank you for coming. I don't know if this met your expectations or not, but this is we're glad you're here.
Yes, I've learned a lot, and slowly I go into this hobby.
Okay. No, you're welcome. Come back every week. We'll be here every week.
Okay, thank you.
All right. We'll see you guys. Bye.
Bye.